day.
Okay.
He said, I haven't watched a single one of those videos yet.
Really? Okay. Must be good.
I shouldn't appreciate it.
Alright, I will say
He
this.
said it's about to.
On the quiz, if you write in the corner of your test or quiz, math is awesome, you'll get 10 bonus points.
Which corner?
Okay, top corner, on the right. Yeah. There we go.
Is this a hard quiz and you're taking pity on us?
No, we're just going to see who watches the video.
Oh, you're recording. I got you.
So it doesn't leave this room unless it leaves on this video.
Alright, so we can't tell them.
Yeah, she knows.
Okay?
That's smart.
Alright. Okay, so, let's talk about... What?
What was the phrase?
Okay. The inverse of an exponential function is a logarithmic function. So let's talk about some properties of functions that are invertible. First, functions must be one-to-one in order for their inverses to exist. Remember what one-to-one means? Do you remember that?
Yes.
It's because it's from like 100 years ago.
For every x, there's a y.
Uh-huh. And the other way.
Y, there's an x.
Right, because to be a function, it has to pass the vertical line test. To be one-to-one, it has to pass the horizontal line test. So we talk about x can't repeat. Well, in order to be one-to-one, y can't repeat either. Okay? So it says summarize how to determine if a function is one-to-one or not. Like what we just said, it's one-to-one if there's only one y value for every x and only one x for every y. X can't repeat, y can't repeat. It has to pass the vertical line test and the horizontal line test. Like, take your pick. Any of those that you want to say, that's how we know if it's one-to-one. Miss Brown, the math question.
That's all we do.
Okay. So consider for a moment the exponential function f of x equals -2 to the x plus 3 plus 2. It's graphed right here, and then you got a table of values to remind you about the transformation. Because we talked about these transformations, that was in the last chapter. You may have forgot about that. Feels like a year ago. Alright, so to find the inverse of a function, what is done numerically? What do you do numerically?
You just switch that to y.
Yeah, just switch the domain and range. That's it. So, switch domain and range. That's how I felt about that copier this morning. Like every third copy, it jammed. Alright, the graph of an exponential function has a horizontal asymptote. When the inverse is formed, how do you think this appears in the inverse function? Yeah, the horizontal asymptote appears as a vertical asymptote. That's right. Alright, so we've got this exponential function up here. Make a table of values for the inverse function and then graph it. So if it's at 5, or it's at -5, 1 3/4, then the inverse is going to be at 1 3/4, comma, -5. You just switch them. That would be 1 1/2, -4, 1, -3. So up here we had a horizontal asymptote at 2, so we're going to have a vertical asymptote Yeah, that one was at y equals 2, this one's at x equals 2. You have no idea how aggravating it is. Who's she talking to? Can you recognize the other voice?
No clue.
I don't know.
I thought it was Miss Brown, but that doesn't sound like Miss Brown.
No. Kind of sounded like Miss Christie, or Miss Woody, I mean. There you go. Alright, does everyone have this graph? Now let's find the equation of the inverse of f of x. Remember, to analytically find the inverse, what do we do to the equation? Change what?
Swap the x and y.
Yep. Swap the x and y. It's not sway. You can sway them, or you can swap them. And then after you've swapped the x and y, what do you do?
Wait, what?
After, when you're trying to find an inverse and you've swapped the x and the y, then what do you do? Like you put the x where the y was and the y where the x was. Solve for y. And then change y to the inverse of f of x. I'm going to sharpen this pencil. Alright, so now perform the process you just described to the exponential function f of x equals negative 2 x plus, to the x plus 3 plus 2 to find the inverse of the function. So that's going to become x equals negative 2y plus 3 up here plus 2. How do I solve this? What do I need to do first?
Subtract 2 from both sides.
Alright, so I got x minus 2 equals a negative 2 to the y plus 3.
Did you switch it to logarithm?
Not yet. I need to get rid of this. So I'm going to make this
Divide by
negative x plus 2 equals 2 to the y plus 3. Change it to log base 2 of negative x plus 2 equals y plus 3. Or y equals negative 3 plus log base 2 negative x plus 2. There you go. Alright, try those 3 right there. Find the inverses of those 3. Yeah. Ooh, good save. There you go. Check it.
Oh, so when you divide each side by -1 on the first one, you can change the sign and tell the log and everything?
Where are we looking?
Like when it says -y equals -3 plus. So like when you divide each side by -1, you flip the sign inside the log too and everything.
No, it stayed the same. It went from -3 plus to 3 minus.
Oh yeah, that's for some reason I had a wrong sign there. So you only flip the sign at the one outside of it?
Right.
Okay, I didn't know if the -1 was supposed to affect you or not, so I just put it all over -1.
Actually, I got another.
All right, we good? Okay, let's look at the next page. All right, so on the previous page, you found equations that represent inverse functions of 3 exponential functions. Now, we're going to complete this table about the exponential functions and about their inverse logarithm functions. Okay, so for the exponential function, what's the domain? For this, what's the domain? Mm-hmm. To infinity for this. What's the range of this?
-3.
Say that again.
Oh wait, no, is it?
-3 to infinity.
Yeah, 'cause it's -3. Okay, yeah. This
Mhm.
is coming back now.
So your horizontal asymptote is at y equals -3. So the domain and the range and the vertical asymptote of the inverse. So the domain is going to be what?
-3 to infinity.
Right, because remember the domain of one becomes the range of the other. So then the range would be, right? And your vertical asymptote would be x equals -3. What was your equation of the inverse function? Wasn't this the one that we changed to 3 minus? So the argument of the inverse of f of x equal to 0 and solve, that's the x plus 3 part. Set it greater than or equal to 0. No, sorry, just greater than.
Can you scoot it over?
Is that good? Don't like this pencil. So I'll try and use a pen, but the moment I try to use a pen, I'm going to mess up. Alright, what's the domain on this one? with the E.
Negative infinity, infinity.
And the range,
Negative infinity to 3.
and the, no, isn't it 3 to infinity? What did I do? It's 3.
Oh yeah, because it'd be over
positive.
the asymptote, right?
Mhm.
Yeah.
I knew as soon as I started using ink, I would mess up. And then what's your horizontal asymptote? Y equals 3. So now over here, the inverse, the domain, is, and the range, and the vertical asymptote
X equals 3.
the inverse of f of x on this one was a negative 2 plus the natural log of x minus 3. Right? So then you have x plus 3 equals 0, so x equals negative 3,
It's
x minus 3.
It's the pen.
It's the pen. I know it. You're using a pen. X minus 3 is greater than 0. So x is greater than 3, or from 3 to infinity. Do you kind of see what's happening here
Mm-hmm.
and here? Yeah. All right, last one. What's the domain on this last one? Infinity to infinity. And the range? Yeah. You should be more confident in your answers. How about the horizontal asymptote? Y equals 1, but yes. Alright, over here, so this means that this domain is negative infinity to 1, and this range to infinity. And then the vertical asymptote is x equals 1. So negative x plus 1 equals 0, negative x equals negative 1, so x equals 1. That was it. Negative x plus 1 is greater than 0. Negative x is greater than negative 1. X is less than 1. Why did that go from a greater than to a less than?
Side by negative.
Yeah. Divided by a negative.
I remember when we did that in algebra when it was tripped me up.
Yeah.
So now I don't forget it.
Fool me once. Alright. I'll punch you in the face. Alright. Based on the information in the table on the previous page, what inferences can you make regarding how to analytically find the following characteristics of a logarithmic function given the equation of the function? How can you find the equation of the vertical asymptote of a logarithmic function? Sorry.
Set argument equals 0.
Yes. Set the argument equal to 0 and solve for x. How do you determine the domain of a logarithmic function?
You set the argument greater than 0.
Yep, and Solve for x. How do you determine the range of a logarithmic function? It's always what? Trying to record here. Making all that racket. It's always negative infinity to infinity.
Oh, yeah.
All right, number 1. What's the equation of the vertical asymptote?
X equals 2.
How do you know?
Set the argument equal to 0.
Yeah, because you get a negative x equals a negative 2, so x equals 2. What's the domain? Well, make it greater than 0.
X is less than 2.
So you're looking at from negative infinity up to 2. What's the range?
Infinity, infinity.
Yep, because it always is. Does
We got that in the free response.
does the graph lie to the left or the right of the vertical asymptote?
Left.
Right? How do you know?
All the values. Like, or it's like negative.
Right. The domain contains all values to the left of x equals 2. All right, try to do that one by yourself. All right, so the equation of the vertical asymptote, you set your argument equal to 0 and solve for x. So what is x here?
3 halves.
3 halves. And then on your domain, you set your argument greater than 0. This one, the sign's not going to flip. So x is greater than what? 3 halves. So this one says, okay, if x has to be greater than 3 halves, then my domain is from 3 halves to infinity. Range is always from negative infinity to positive infinity. Does this graph lie to the left or to the right of the vertical asymptote?
Right.
Right, because
Domain contains all values to the right of x equals 3 halves.
exactly, the domain contains all the values to the right of x equals 3 halves. Exactly. Okay. The next page uses a table, and I'm not going to give you that to do without us going over it. So we'll just work on that tomorrow.